All right, so I'm over at the open-unmix repository, and you can start by just clicking on docs, and we'll be taking a look at the training.md file. So there are a lot of dataset formats that are supported by open-unmix. Like by default, it's actually used for music. So it works with this dataset called MuseDB18. But what we're interested in is the source folder dataset. So if you come all the way down here, you'll see source folder dataset, and it has a tree structure here. Now, this is kind of hard to understand, so I'll just pull this up, and I'll give you guys a tour of what our data is going to look like once we format it. And most of the work is actually done right here in the formatting of the data. So if you look at it, we've got a train and validation directory. Go into train. And so again, source folder would mean that our sources are actual folders that make up our data. So all of the podcast samples will be contained within here. So we'll have these 5-second wave files of the podcast. So we're going to have to take podcasts, breaking them up into 5-second intervals. By default, open-unmix will expect 6 seconds, but because ESC50 by default is in 5-second intervals, that's what you're seeing here. So the interfering audio is the 2000 files from ESC50. And if you go out, the validation looks the exact same. It just has a lot less data in it. So now let's actually go over how to get the podcast. So you're going to want to make a directory called JRE podcasts. And you can put, well, when you download from their website, it'll download MP3s. We're going to need to convert these MP3s into WAV files because loading WAV is much faster since it's uncompressed audio. And so let's actually go to podcast.joerogan.net. So if I go back here, and it's got all the podcasts. So you don't have to use the ones that I used. I only used 10 podcasts, by the way. But you can just start, like, you can click on one, download this episode. And then you could actually click here and you could download all your MP3 files that you want to use. So go ahead and do that. And then we'll also talk about ESC50. So all their data is actually already in the repository. So you're going to want to grab it. And we're going to clone ESC50. So I'm not going to actually do it, but you would come into terminal, get clone, grab it. Okay, it should take a while to download because it's like 600 megabytes or something. And let's actually go over, so there's two directories. There's the directory where we're going to put our data, and then there's a directory where we will put our code. So if we go over to, and I'll just make one. Let me see if I go back to here, you can git clone this repository. Come down here. I always forget that command. I'll need it for later. And I want to git clone this, and I'll call it UMX demo. And we'll go in there. So now we actually have to install a Conda environment. So if you did something like Conda info envs, you'll see I've got a bunch of environments already installed. What you want to do, so if you want to name, and another thing, you'll see, so the way Anaconda does this is with YAML files. If you're on Windows, what you want to do, it says they haven't tested this in Windows. So if you really are like hard stuck and you want to try it on Windows because you don't have a Linux thing, you can go into one of these YAML files. So this would be environment GPU Linux CUDA 10. And if you want to name it something else, you can come up here, and I'll just call it like demo because that's what I'll name it. And then, but if you're on Windows, go through here, create an Anaconda environment with Python 3.7, and you can try to pip install all of these specific dependencies, and hopefully they should all install. If they fail, then you might want to consider booting up Linux, okay? So I'm gonna, I'm in nano, by the way, so I just nanoed into the file. Control X will save your, well, will exit the file, and then you can hit Y to save. It'll prompt you the name and you can save that file. So now if I were to go back in, you see that the name is called demo. So that'll be our conda environment when we install it. So if you go back to here, you would say conda environment create F, and then you can install your conda environment from a YAML file. In this case, it would, I can't spell, it would be this one. And this will probably take a while. Actually, this is kind of going quite quickly. No? Yes? Oh, everything was cached. Okay, so I actually just did this. So all the files were cached, which was quite nice. But you can see that it went through the whole install. Yours is probably going to be slower. And then you can just conda activate demo or whatever you called it. So now I'm in the Anaconda environment. If I did pip list, you would need all these things installed within pip so that everything would work okay. So if you're on Windows, make sure you have all of these packages installed. Good luck with that. And so now we'll actually start writing the first part of the script for converting our files from MP3 to WAV. All right, so I'm over here in Atom. I've opened up UMX demo, and we're going to be creating a file called sourcefolderformatting.py. So go ahead and create a Python file and grab these imports and put them at the top. And just so a brief review, you guys should have a directory called JRE podcasts, and you have all your MP3 files. This WAV directory shouldn't exist, so I'm actually going to go ahead and delete it. But let's go ahead and make something that can convert those MP3s into WAV. So the first thing we're going to do is make a function called checkdir, and we're going to be using this a lot because that's not correct, should be saveddir. So this function is basically just going to be checking a directory, seeing if it exists, and if it doesn't exist, we're going to make a directory there. So if it doesn't exist, we'll say os.makeDirs of our save directory. And now we're going to, so wherever you actually put your data, for me, it's like home, set, datasets, open-unmx. We're going to create a variable called umx-path, and that'll just be home, set, datasets, open-unmx, or open-unmix. Okay. And now we're going to list all the podcasts that are in the MP3 directory. So generally, it's best to use os path join. So we're going to go into umx path. It's going to be called, really you can call it whatever you want, but it's JRE podcasts MP3. And so that should return a list, and we're going to checkdir. So that function that we just created, we want to check os.path.join of umx path. And the reason we're doing this is the WAV directory probably doesn't exist for you guys, so we'll go ahead and create it. And so here we're going to be converting our MP3 into wave files. And let me actually make sure I didn't make a syntax error there. So I deleted that. I'm gonna come down here. Cool, that ran. If I check back over here, now I've got an empty wave directory. So let's actually fill that up. So we already have our podcasts listed out. So we'll say for pod in podcasts. Our name is going to equal to pod.split. So pod is actually a string and I want to get the name of it. So I will split on the period because they're MP3s. And then we'll actually create something called MP3 path. And that's just going to be equal to where our MP3s are. But now we just have pod. Now pod has the extension, and now we want to create a wave path, and wave path is going to be the exact same as this top line, but we're going to want to create a wave, and I guess we'll say pod plus, or actually, sorry, this is name, so we just split this on the period, and we'll say wave plus dot wave because we need that wave file extension when we go to save this. And then we'll say if os.path exists of wave file or wave path. So we're going to query and say, hey, does this wave file exist at this path? And if this is false, we're going to actually run fmpeg. So this is the part where we would run fmpeg from like command line. So that's what os.system does. It'll kind of go in and let you run any kind of command line from Python. So this is actually an fmpeg command. And because it's kind of long, I'm just going to copy and paste it. But it looks something like this. So fmpeg I, so this is going to convert our audio file into a wave. You'll see a 44.1 kilohertz because that's our sample rate. If you have a different sample rate, actually no, if you're following along with the data, it should be 55.1. If you have your own data, that's kind of up to you, because there's a lot of changes that kind of have to be made within open-unmix to get it to use a different sample rate. But so this is string formatting, so we just want our first string to go here and our second string to be added in here. So we want to convert our MP3, so it's going to be MP3 path into our wave path because it doesn't exist. And hopefully I did that correctly. So I'm going to actually come up and run this here. I have a syntax error. That's cool. Forgot that. Okay, cool. And this is fmpeg. So it's doing all kinds of stuff. Actually, let's take a look at top here. Yeah, fmpeg has a lot of output, so this is going to look kind of crazy for a while, actually, especially if there's weird errors. A lot of times this isn't, like, you'll see stuff like this, don't worry about it. That's pretty normal. fmpeg is really frustrating, but if we open up here and go into wave, you'll see that it's starting to create all these wave files. And they have a sample rate of 44.1 kilohertz. And so I think that'll do it for the first part. And in the next video, we're basically going to be continuing this file, and we're going to be building out using the waves we just created. We're going to be slicing them up and building out this data directory. And that's actually quite a bit of work, so we'll just allocate another video for it. And I'll see you guys there.